whoa, rockets are amazing. What a great example of innovation and a great inspiration to building our own bottle rocket. For a list of everything you'll need to do this experiment, check out the link in the description below. Now let's get started. First, we have to make sure our cork fits tightly into the nozzle of the pop bottle. With adult assistance, use a nail and pliers to hammer a hole through the cork while wearing protective gloves and goggles. Don't hammer the nail all the way in or it will be hard to remove later. Test that the pump needle fits nicely into the cork's hole you just made. Also test to make sure it has a tight seal around by pouring water into the pop bottle and sealing it with the pump needle in the cork as well, and turn it over to see if it leaks. This is the foundation of our rocket. Next, cut your recycled cardboard into 3 or 4 equal triangles to create fins. Later on, you can try to customize and see how the number of fins and their shapes affects how the rocket behaves. Cover the fins with duct tape to help minimize water damage. Tape the fins to the flat part of the bottle closer to the nozzle so the fins can act as support when launching. For making the cone, I use my bucket to draw a circle on a piece of cardboard, then cut it out using scissors. I then cut the circle cardboard into half and taped half a circle together like this to create a nose cone. Then I covered it in tape to make it sturdier and protect it from water damage. Attach the cone to the nose and your rocket is complete. Once the rocket is complete, play around with the base you've chosen to try to stabilize the rocket. I just cut a hole in styrofoam for my rocket to sit in. I also have a retort stand as backup. Once you've figured out how to stabilize your rocket on your launchpad consistently, it's time to move this party elsewhere. Open outdoor space away from people and things your rocket can get stuck on, like buildings or trees, is best. Once you start pumping, do not have anyone approach the bottle rocket. Even if it appears nothing is happening, the rocket can suddenly launch and cause an injury. Also, if you are too close to the rocket while pumping, you can sometimes find yourself in the splash zone and end up wet. To minimize this, launch the bottle rocket without water or attach a longer hose to the bicycle pump to allow you to stand further back away from the launch site. Alright, we're good to test our bottle rocket now. Science experiment time. Taking a closer look at the flight, you can see the different states of a bottle rocket. First, we have the launch ascent as the bottle rocket accelerates upward. Next, we have the caution descent after the water and built up air is pushed out and the bottle rocket starts to decelerate due to gravity. Third is the maximum altitude where the rocket reaches its highest point. And finally, the caution descent as the rocket falls back down. What an amazing flight. But wait, the science doesn't stop when the rocket hits the floor. What happens when you fill your rocket completely with water? What happens when you don't use any water? What happens to different volumes of water? Try it out and graph your results using the time as the y-axis and the volume percent of water as the x-axis, and see exactly why I recommended 40% water. Are you ready to try this at home? Be sure to share your results with us.